But tonight we're going to talk about the one that's coming up soon. I'm so excited. And we are pleased to have with us from the Imagination Station, Big Cheese head scientist Carl Nelson and Sloan Eberly Mann. For a woman whose name Marianne Britt Duvendack, you think I could get that straight. They're here with us tonight to talk about things that are going to happen eclipse-wise, things that will happen here in Toledo eclipse-wise, things you can see where you can go. So take it away.
All right. Well, thank you very much, Marianne. We appreciate it. We appreciate being here with all of you this evening. We had the good fortune of Marianne joined us for our Solar Eclipse Ambassador Program. So one of the things that we recognized about a year ago was this was going to be a big deal here in our community. And a lot of folks weren't even going to realize what a big deal it was until it was upon us. We're a relatively small staff. We're a mid-sized science center. We have about 30 full-time folks, another 50 part-time folks. So we knew we could only do so much, right, beyond our normal operating capacity to support educating the community. So we had this idea to identify Eclipse ambassadors who we were going to train and give resources to provide support over time, and they could go out and educate their audiences. So Marianne's a wonderful example with the work she does with all of you, and then the Girl Scouts. We had a whole slew of individuals that really expressed interest in the program, which was the best part. The cynic in me was like, well, you know, we'll be lucky if we get 20, 30 folks to sign up. Our goal was around 40. We had over 100 applicants. And then I went through this kind of silly process of trying to like decide who we were going to educate. And then it occurred to Carl and I like, well, these people want to learn science and they're geeked about it. Like, what could be better? So we invited all 100 plus folks to come and join us. And it's really been a lovely experience. We have a lot of educators. We have folks that work in libraries. We have a gentleman who is a bartender on Catawba Island that, you know, they're going to have a big old party on the island and he wants to be able to talk the science. So it's really been a great experience for us as a science center. In addition to our work with the ambassadors, we've delivered over 250 programs in our community to school kids here in Lucaswood, Hancock County, educating them about the science of the solar eclipse. We have an inflatable planetarium called a Star Lab where we can simulate the eclipse in advance. So we've been able to show kids that. And then we created 700 totally solar kits, which I can see a totally solar kit sitting right there. We gave those to all our ambassadors. There's 6 different activities. There's information about the science of the eclipse, safety, 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 which is oh so important, and we'll talk about that tonight. And then we mailed out 500 kits to school children in Lucas County, Wood County, and Hancock County. So we've been at it for a while, and I think we're all going to rest on April 9th, but we sure are excited for April 8th. So let's here. Maybe. Just one moment, apologies. Why did it like you and not me?
It just wasn't focused.
Oh, perfect.
And then there's little arrows.
Okay, thank you very much. Well, I'm assuming this audience already kind of has bought into the excitement of the eclipse. I see some heads nodding, which is wonderful. But why do we care about this? Well, one thing is just to think about the impact for our community. So we know that our population here will likely double. That's revenue in the terms of, bed tax, restaurants, shops here in our community, which is fantastic, showcasing Toledo in the best possible light. There also is what I think is most exciting, just the fact that there's such a light lift on the part of people participating in the eclipse in order to be part of it. So all you have to do is walk outside and look up, right? We can all do that. We can all share in the awe of it. So even for folks that don't have a deep understanding of, the science behind it, even just a basic understanding, you can really appreciate the wonder of the universe. And Carl and I haven't had the good pleasure of experiencing a total solar eclipse. We both experienced the partial in 2017, and then Carl was in Oregon for the annular eclipse back in October. But we have 2 individuals in the audience who've had the joy of experiencing totality. So certainly, if they want to share anything at the end, more than welcome to. But speaking of experiencing the eclipse, I'd like to show you a brief video here. And should just advance to play. Oh, perfect. Thank you.
Oh,
So crazy.
how dark it is out here.
It was amazing. Like you stop
When that diamond
and it kind of felt like love.
Heard little crickets come out chirping and all that because it got dark and I don't know. I felt the temperatures rise.
Celestial things are just beyond comprehension. And when you see one and it's really there, and we're all here.
No matter who you were, what your beliefs were, what your goals were.
Sort of let you see where we sit in the cosmos.
You know, because we all are experiencing life the same way. So
what color, what anything. Everybody's like,
I think it's something we all really need right now. It's just to feel connected in a way.
there was such a camaraderie and friendliness, and we were literally touching and hugging each other.
I bet the whole world was looking up. I bet the whole world was looking up.
Thanks for the video. And that's such a great video. It gives us a sense of what the experience of being in totality is like in modern times, but that has not always been the way that eclipses have been received. So I'm going to invite Carl up here to talk a little bit about that.
Yep. So Sloan's right. Through most of human history, like people don't get excited like that for eclipses. Mostly it was end of days. It was end of times. You know, the sun had disappeared, and the sun is what gives our planet life, right? That can grow food. We can be warm. We can not be an icy ball racing through space because of the sun, right? And when it suddenly disappears, and you don't understand like the celestial mechanics of what's happening, it can be a very scary experience. And so most people create stories then to explain what's going on, right? And so if you think about what a partial eclipse looks like, it kind of like there's a bite taken out of the sun. That leads to stories of like demons or dragons that are in the sky that are eating the sun, which is, you know, terrifying. And so then you have to figure out a solution to that, right? You want to drive the demons and the dragons away. So you're going to beat on pots and pans. You're going to scream or sing into the sky to try to make them go away. You might even go so far as to shoot flaming arrows into the sky because you're trying to rekindle the sun. And there are stories of people out west, like, you know, the sheriff comes out into the street and shoots his revolver into the sky, and magically, you know, the sun comes back, right? And that's the beauty of it, is that every time all those efforts worked, the sun always came back, no matter what they did. And it can be a dramatic experience, even, you know, in terms of like in 585 BC, the Medes and the Lydians were at war for 6 years. And then in the middle of the day, the sun disappeared. And both sides took it as a sign that they should stop their war, which they did. So it can have big implications for society. Even bigger implications for science. You know, I think we think of Albert Einstein as this amazing scientist, which he was, but his fame, his like rock star sort of status didn't really kick in until after the eclipse of 1919, when his theory of general relativity was sort of verified during an eclipse. So theory of general relativity is, you know, you have massive objects like the sun. They can actually warp space and time, which is a really deep thing to think about. When he came out with this theory, there was a newspaper article that only 6 people in the world could understand what he was talking about, right? And it was something that you couldn't verify in a laboratory with beakers and test tubes and burners and things like that. You needed something on the scale, the solar system of the universe, to be able to verify that. And so that's exactly what they did. And the idea is that you would go out and look into the night sky and take a photograph, get an idea of where the stars are. And then you wait for a solar eclipse to happen so that that starlight has to pass by this massive object, the sun, and that would cause a sort of a distortion in where those stars appeared. And so here's a little animation. We got our massive sun. We have a star out in space. And as that light passes by it, it's deflected. So on Earth, that star looks like it's in a different location than where it really is. And so if you compare those slides between the eclipse and not the eclipse, here's the actual photo they did in 1919. And it's probably hard to see, but there are like little hash lines, little horizontal lines that show the positions of like 7 stars. And they actually shifted as predicted by his theory. And like all good scientists, the next time an eclipse came along, they sent people out and did the same sort of thing. And again, it was verified. So just to make sure it wasn't just a one-time deal. So it's amazing how his popularity or his status in the public was elevated after this, because it's like, wow, he's right. This thing that only 6 people in the world could conceive of was actually proven or verified during a solar eclipse. So during our solar eclipse of 2024, the sun is going to be about 60 degrees up in the sky. And that's great because no matter where you are, you're probably going to see it. You know, your home is probably not going to block it unless you're standing right next to the wall, right? As you mentioned earlier, you know, that path is about 100 miles wide. It's traveling 2,000 miles per hour when it hits Mazatlan, Mexico, and it's going about 4,000 miles per hour when it leaves Newfoundland. And you know, for us in Ohio, that path is gonna that shadow of the moon is gonna travel over Ohio in about 11 minutes. In downtown Toledo at the Science Center, we will have 1 minute 54 seconds of totality. At Sloan Eberly Mann's house, you will have 5 seconds of totality. So it's really interesting. We'll look at it more closely when we look at a map, but that time can vary. If you're in Findlay or Wapakoneta, you get 4 minutes of totality. So, you know, the last time a solar eclipse passed through Toledo was 1806. Lewis and Clark were finishing up their expedition. Toledo had we been a city? Were we? No, we weren't even a city yet, right? Right. And the next eclipse to hit Toledo is going to be in 2099, right? That is my Spideyverse version of what Toledo will look like in 2099. We don't know, right? Yeah. So we're talking about that path, right? Before we go into the totality path, look in the bottom right-hand corner here, and you can see it's sort of all of North America is covered by that grayish blue path. That is the path of the partial eclipse. All of North America will experience to some degree a partial eclipse. But we are special in that we're in that path of totality, that dark band, and that is where the sun will be completely covered by the moon. And if we zoom in a little bit closer, you can see that Toledo is right on that edge of the path. In some of our prior trainings or prior presentations, we've had people like, we can pull up a detailed map to see exactly where you are. Like Sloan said, her house is like right on the edge. She gets 5 seconds of totality. So it's an important thing to note that this band or this shadow path, the closer you are to the center, the longer that shadow is passing over you. If you're right on the edge, you might only get 5 seconds or even nothing because you're so close to the edge. Another interesting thing that I think is really geeky here is if you look at the shadow, you can see it's not a perfect oval. It's like a polygon. And that's because the people at NASA are very smart, and they've actually been able to map the surface of the moon, map the surface of the Earth, and take into account the lumpiness, if you will, of the moon, where the craters are, the elevation, probably not so much until the Toledo area, but out west, you know, the elevation of the ground, and come up with a very accurate representation of where that path of totality is. If you zoom in even closer here into the Toledo area, I like to joke that there is a path, or the edge of that path actually goes from the House of Meats on Alexis down to Aldi on Monroe. If you're below that, you'll be in some sort of totality. If you're right on the edge, you'll probably get no totality. But if you're above it, like in Sylvania, you'll get no totality.
Is that Olinder? Right in the middle of the screen, is that Olinder?
Okay. Yeah.
Okay, so they're out.
So it is worth your effort. It's worth your time if you can to move as far south as you can to get into the center of the path. Maybe, you might not want to go to Wapakoneta, but certainly go to downtown Toledo. You get 2 minutes of totality versus Sloan. I think you looked up this location. How long was it? Okay, Secor and Alexis is 27 seconds, if that's any sort of reference for you. So again, if you can get further south, much better. And this very complicated slide sort of tries to get at that with those arcing bands showing what the duration of totality is where you are in the state. So we're on the edge. Dublin, just north of Columbus, is the sort of the equivalent to us on the other side of that band. And then just really quickly, some times for various cities throughout Ohio. You can see the number there for Toledo is for downtown at the Science Center in Festival Park.
So did that say minute 4 seconds? Minute 54, yeah.
Yes.
And Bowling Green is that 258.
Yep. That's a close drive. It could be worth it. It's a 30% increase, right? So if you think about across the whole US and the 2017 eclipse that we had, this path of totality passes through a lot more higher population centers. So 31 million people are within that path of totality, 75 million if you consider like 100 miles on either side, which is an easy driving distance, right? And I think Sloan alluded to this in the beginning about how we could see an influx of people coming into our community just to get into that path. So let's talk about some of the science behind the eclipse. And the first thing you got to talk about is the moon, right? And one question that you might ask is, if the moon is orbiting the Earth and getting in between the sun and the Earth, why don't we have an eclipse every month? And that's a great question. And the answer is on the right-hand slide there. It's because the moon's orbit is tilted a little bit. It's tilted about 5 degrees relative to the orbit of the Earth around the sun. So I actually have a little animation here that's kind of fun. It's not to scale at all, but you can kind of see as this tilts on its side that often the moon's shadow falls either above the Earth, and so we don't get an eclipse. And then as it continues to orbit, it can end up again with that 5 degree tilt. It'll fall below the Earth, so again, no eclipse. But then, as you can imagine, there are times, which we know, that it does actually fall right on us, and that's when we get a solar eclipse. Another way to look at it, this little diagram here, kind of gets at the idea that 2 times during the year, there are what we call it like an eclipse season. And for you guys, it's kind of interesting to get into the weeds a little bit, is that those eclipse seasons don't actually happen exactly 6 months apart. It's a little bit shorter. So the time period when you can get an eclipse sort of creeps around the clock, if you will. It means it's possible you could have 3 or 4 solar eclipses in a calendar year. Okay, because it's not, the numbers aren't even. They don't magically, they're not integers. They don't round out. But Earth is the only rocky planet, the only planet you can stand on that has a moon that'll actually give us a solar eclipse. If you could stand on Saturn, which doesn't make any sense, it's a gas giant, you possibly an eclipse. But typically you get 2 eclipses per year, solar eclipses. And often we talk about eclipses as being a rare event. What's rare is that it happening at the same location on the planet often. So like you saw before, 1806 to 2099 or 2024 is when it hits Toledo, right? So it could be 300 years between a hit at the same physical location on the planet. If you happen to be a time traveler, this 18 years, 11 days, and 8 hours of the Saros cycle is an important number to remember, because from any given eclipse, 18 years, 11 days, and 8 hours later, another solar eclipse will happen. But because of that 8 hours, it's going to be shifted westward around the planet 120 degrees, or a third of the way around the planet. So if it happens in Europe, and then the next one will happen probably in North America. So it's interesting that, we think we're so smart these days with all of the science and technology we have that we can predict eclipses. But, 4,000 years ago, the Sumerians were able to predict eclipses, both lunar and solar, because they kept a lot of data. They gathered data. They made observations of lunar eclipses, solar eclipses, and were able to then figure out, in addition to just that sorrow cycle, that the eclipses come in a pattern. They could actually predict them, which I think is really kind of cool. And so here for the past few years are some of the solar eclipses we've had. It's a mix of partial, annular, total. And again, because of that eclipse season, anytime there's a solar eclipse, either a couple weeks before or a couple weeks after, there'll be a lunar eclipse. And for us, on March 25th, it's a Monday, there will be a lunar eclipse. It's going to probably be kind of hard to see because of the type of eclipse it is, which we'll get to in a second. But there will be one happening. It starts at like midnight and goes until 4 in the morning. So for a solar eclipse, the basic idea here is that the moon casts a shadow on the Earth, and it can cast two kinds of shadows, umbra and a penumbra. And it's in the umbra, the darkest part of that shadow is when we get that path of totality, where we have the total solar eclipse. You can contrast that with a lunar eclipse, which I think is interesting because here the Earth is casting a shadow on the moon, and during that time, half the planet can view the lunar eclipse. Whereas you think about a solar eclipse, we're talking about a shadow that's moving 2,000 miles per hour, and it's a narrow path, maybe 100 miles wide. It's a much more exotic event, or a much more special event than a lunar eclipse. And so the reason I said that the lunar eclipse on the 25th will be kind of hard to see is because it's not falling in the umbra, that darker shadow. It's actually falling in the penumbra on the outside. So it might be a little bit harder to see. I love this idea that, the moon is 400 times smaller in diameter than the sun, but it's also 400 times closer to us. So it just works out that it can block the sun totally during a total eclipse. Now, of course, the moon's orbit isn't a perfect circle. It gets a little bit further and closer to the Earth. So that's where you get the origin of your annular eclipse. The moon is a little bit further away, so it's not quite big enough to cover the sun. And so you see like a ring of fire. Okay. I love this idea of talking about the scale of the solar system and whatnot. So if we were to scale the sun up to be 109 times larger than the diameter of the Earth, it would sort of look like that. But now if we sort of scale the distance between the Earth and the moon, 30 Earth diameters away would be the moon. And now we scale the distance between the Earth and the sun. And to me, it's just amazing that, those shadows can line up. Just given the enormous scale. The moon's casting a 250,000-mile long shadow into space. And, it just has to hit us at the right time to create that eclipse. Are you going to talk about safety, Sloan? Is that what I think I'm doing? Okay. Okay, so during an eclipse, safety is really important, right? That's why we're talking about passing out solar eclipse glasses. During the partial phase, I should back up. Anytime you look at the sun, you need protection. So during the partial phase, you need to have the solar eclipse glasses on to look directly at the sun. During totality, you take off your glasses, but in this case, the moon is your protection. The moon is completely blocking the sun. You should never look at the sun directly. I know we've all probably done it. You've glanced, right? It's not a good thing to do. And then the partial phase after totality, which lasts about an hour and a half, you'll need to wear your glasses as well. So you have an hour ahead of time, an hour before totality, 2 minutes of totality downtown Toledo, and then another hour and a half of partial phase afterwards. And at all times, you want to go ahead and wear some sort of protection.
The after is longer than the before?
It is.
Why?
Good question. I don't know. It's just the way it works out. Just the way it works out. So again, with your solar glasses, you want to make sure they are meeting that ISO standard. I think during the 2017 eclipse, we had some glasses out there on the marketplace that were not certified as meeting the strict requirements of blocking 99.999% of the sunlight, blocking the UV and the infrared. So just make sure you look at your glasses, check them out, make sure that they meet that sort of standard. Here's some people enjoying eclipse back in 2017, wearing their glasses, you know, looking at the sun. And then the other way you can approach this is, instead of looking directly at the sun, you can do an indirect method. You can use something called a pinhole viewer. The simplest version of that is you take a piece of cardboard, poke a hole in it with a pencil, and cast a shadow on the ground, and you'll see that bite taken out of the sun during the partial phase. Of course, you don't need that during totality because you can look at the sun. Another way to do it is to, you know, poke a hole in a cardboard box and it casts a tiny shadow inside. You look inside the box. And back in 2017, we made a bunch of those. People have been doing it for years. There are people back in the 60s, really big boxes, and they have a hole in the back. And yeah, the teacher, it must be cloudy. I don't know. So don't post this on your social media feeds this time. Right, so that's a great point. If you notice on the back of the boxes, there's a little cutout, and that's where they put their aluminum foil. They poke a hole there, they put their head inside the box, and they look away from the sun, because you're looking at the image that's cast inside the box, which is why he is looking, hopefully, at the obscured sun with the shadow, with the clouds in front of it. But there are a ton of ways you can do this, right? Recently, it seems like the internet is a fan of the colander. You can take a colander out and cast shadows on the ground, and it'll look like there's a little light taken out during the partial phase. Sloan is encouraging saltines. She has heard that saltines can do the same sort of thing. But basically anything that has some sort of holes in it. You can take your fingers and crisscross them like this, make a hole, and you cast a shadow. That'll do it. Even leaves on trees, although for us, maybe there won't be so many leaves on trees. April, maybe, I don't know. But it's kind of cool that even the spaces between the leaves on trees can create cast that sort of image on the house. We've got some fancy stuff at the Science Center that makes large images so that a lot of people can view it. But the thing you don't want to do is don't do this. Don't try to wear a pair of sunglasses, or don't try to be smart and think, well, 6 pairs of sunglasses will be better, because they're not going to block the infrared light. They may block the UV, right? So the sunglasses do that, but they may not block the heat energy. And so it's still not dark enough. And the solar eclipse glasses, they're like $2 or $3. They're so cheap. Make sure you get some of those.
Solar glasses block UV.
They block both UV and infrared. Yeah. The sunglasses block the UV light. And I think Sloan even has a demonstration of that we can do with a UV light. But if you stack up a bunch of sunglasses, it still won't block the infrared light. So, yeah. And again, they're so cheap. Just get the solar glasses. Oh. It's kind of on a roll. Keep going. Keep going. But the other thing you don't want to do is think that if you have your solar glasses, then take a pair of binoculars and, wear the glasses, put the binoculars up. Anytime you do something like this, and I know you guys were interested in the solar photography too, is you want to put the filter on the front of the optical device. You put it on the front of the binoculars, or the front of the telescope, not on the back, because the goal for a pair of binoculars is to focus the light. And you can see here these glasses had a little bit of damage there. So something you don't want to do. Fun thing you can do for kids, take a paper plate. Sometimes it's hard for little kids to hold it on their face all the time. They don't quite really fit very well. You could modify a thing like this, but just make sure there's no light leaks and that, the light is completely blocked and only viewed through the filter. So Sloan said, have the activity up here. I have some solar beads. These are just beads that are sensitive to UV light. And this is a UV flashlight. So if I take this light and shine it for the people at home and shine it on the beads, you can see they change color, okay? Indicating they were exposed to UV light. But if we take a pair of solar glasses and another set of beads, and I'll protect them with the solar lens, the eclipse glasses, and take it away, you can see that they are still clear. And just to show you that it's not a fake out, you know, you can, not lying to you, they still are sensitive to UV light. So the Eclipse glasses are your friend. So make sure you do wear those. And you can get these. This is kind of a fun activity if you're hosting a Eclipse party. You can get these on Amazon. They're relatively cheap. People like to make friendship bracelets. So you could do friendship bracelets with the UV beads, and then could be a reminder even after the eclipse when you go outside that you're being exposed to UV light, put on the sunscreen, things like that. I have a little activity for you just to see how you guys perceive the moon. Imagine you're outside in the middle of a dark field right now, and it's a full moon, okay? And it's up overhead. So everybody right now, outstretch your fingers, your thumb and your forefinger. And I want everybody to like squeeze the moon with between your fingers. You're going to pluck it from the sky. How big is the moon in the night sky? Full moon. Okay, so I see a variety of fingers, and nearly all of them are almost like this far apart, which is way too big. The diameter of the moon is the size of a green pea. Green pea. And that is the same size as the sun, right? Because during an eclipse, the moon covers the sun completely. So you're probably thinking of this sort of illusion where the moon is low in the sky and it looks like it's ginormous. But it's just an illusion because the moon is always the same size. It's hard to imagine that when it's on the horizon, it looks giant, that it's only the size of a green pea. And there are some explanations for this. One is that, well, you're viewing the moon next to something you kind of know the size of, and so it messes with your brain, and if it looks bigger, the problem with that is that astronauts in the International Space Station have reported seeing the same effect as the moon rises over the Earth. So it's not really understood what's going on. Some people even say that, well, you know, you're looking through a thicker part of the atmosphere, and so therefore it acts like a lens and it magnifies the moon. If you actually work out the physics, it would shrink the moon. So that's not a good explanation. So, yeah.
Before we leave the safety too far away, someone asked a question online.
Yeah.
We have 15 people. And this is Paul. How can we know if the safety numbers printed on glasses are okay or real? Couldn't anyone just print anything on glasses?
That is true. Anybody could print anything, but if you do go to nasa.org, go to the NASA website, they do list a set of approved vendors that they have certified that are selling glasses that meet the certification. And the same sort of thing happened back in 2017. NASA had a list of vendors that were certified as meeting the ISO standard for Eclipse glasses. Okay. Do I need these? So like I said, on Eclipse Day, the moon and the sun will both be about 60 degrees up in the sky during totality. So you'll be able to see it. And also Jupiter and Venus will be visible in the sky. So that's kind of an extra bonus. Saturn's out, but it's probably going to be too low in the sky on the horizon. You're probably not going to be able to see that. But the sun also goes through an 11-year activity cycle. And we are approaching the peak in 2025 of its activity. And this has been a very active cycle. And so there's a possibility, there's no way to exactly predict this or guarantee it, but there's a possibility there could be extra activity in the corona, solar mass ejections and things like that happening during totality. So it could be an extra special totality. And there's also been in the news recently, I think they call it the Devil Comet. I forget the exact name for it now, but it's a comet that's been known sometimes to be very active and very colorful. And so, again, those are really hard to predict. It could be absolutely nothing, or it could be spectacular. So you just never know. As we talked about, there are different phases to the eclipse. There's what they call first contact, when it first touches, the moon's image touches the sun. Second contact, it's completely covered, totality. Third contact, fourth contact. Those first, third, second, fourth contact are all interesting in that there's an app that we'll give you the link to later on that tells you exactly when those things will happen for any given location on the planet. So even if you have family in Texas, you could look up where their house is and tell them how long totality is, how fast the shadow's moving, when it'll happen. It's really a cool resource to be able to use, but we'll get to that later. So before totality, obviously the thing you can do is look at the partial eclipse, cast some shadows, use your colanders, use your fingers, observe what's happening. It's interesting that because during the partial phase, the sun is going from a big soft box, a big diffuse light, to just sort of a sliver of light. It's becoming more like a point source. It's becoming more like an LED flashlight. And the shadows on the ground will become sharper. They're going to look weird. They're not going to be as soft as you would normally see. And that softness and sharpness has a directionality to it because, as in this image, there's a sliver of the sun that's being visible. So in one direction, the shadows will be very sharp. In the other direction, they'll be spread out because it's still sort of an extended light source in this direction, but it's very defined in that. So if you take two meter sticks and stick them on the ground, you'll see that both and put them at right angles, they'll cast different looking shadows. So just kind of a fun thing to look at. During the partial phase, lasts like an hour, you will probably not even know the sun is being blocked by the moon because your pupils are going to adjust. They're going to adjust to that slow phase until about a minute or two just before totality, when the brightness will drop by 100 or 1,000-fold. And then I haven't seen totality, but I hear or I've read that like the shadows look weird. The color looks weird. It's like a steely gray. It's not quite like twilight. It's not like during a full moon. So look for those changes. Like be aware of that sort of stuff that's happening just visually around you. And then we talked about Venus and Jupiter. Temperature changes, right? When the shadow covers us, temperature could drop 7 to 10 degrees. There could be unusual effects with birds and animals. They could start chirping. Crickets could start chirping. Bats may come out in the middle of the day. If there are cicadas around, I'm not sure if there will be, but they could start chirping and then stop. So, observe the animals around you. If you are around animals, observe the people around you and see how they're reacting as well. It's sort of a fun thing to do. And so one of the first things that people always talk about is the diamond ring effect, where we are just about completely covering the sun. Maybe part of the corona might be visible, but there's still that sort of bright thing that looks like a diamond ring. And a new thing for me was that this year that some people have talked about the possibility of a double diamond ring. There are some locations, I think one path falls near Cleveland, where there may be, again, because the moon is lumpy, it's got craters, there may be a spot where you might see two diamond rings, or two bright spots, two diamonds, I guess, one diamond ring. But after that phase passes, we get to what are called Bailey's beads. And again, this goes back to, again, the craters on the surface of the moon. The last light is sort of sneaking through those craters. You may see little flashes of light, and then they'll disappear, and then we'd be in totality, which is when you can see the corona. That's the only time you get to see it, right? Is during totality of an eclipse. Unless you work at NASA, they've got special devices that can kind of do that. But yeah. What if it's cloudy? What if it's rainy? That's the question everybody asked, right? And the eclipse is still going to happen. It's still going to happen no matter what. If it's lightly cloudy, we're probably still going to see a nice drop in brightness. If it's super overcast, it may not be as dramatic as we would hope for. The only hope we have is that last year on April 8th, it was a bright sunny day. Almost didn't need any jackets or anything. Historically, though, here in Toledo, we have a 32% chance of clear sky. Right? Cleveland has a little bit more to be on the positive side of things. But because of lake effects, as the clouds are coming over, the lake sort of moderates the climate. And historically, they have less cloud cover in April than we do here in Toledo. But I believe you were talking about some of the local meteorologists were talking about it's probably still too far out today to predict the weather on April 8th. And so I think I was talking with Dan Smith from 13 a while back, and he was saying that, we get 7 to 10 days out, you're getting closer in terms of talking about rain, cloud cover, that could be the day of, it just really depends. It's really hard to predict that far out. And this slide we should probably take out because basically it's everything. You could have snow, rain, clear sky, 80s, you'd be freezing, I don't know. So don't worry about that. But Sloan, I think you should really talk about some common misconceptions, don't you? You think I'm doing okay? So it's interesting when you talk to people in the speaking engagements we've done too. One of the biggest things that people have questioned is, do I take off my glasses during totality? Yes. Yes, you do. So if you have friends and family out there, like, remind them of that. Take them off. Like some people, even one of the ridiculous ones was, should I drive with my Eclipse glasses on? And no, don't do that. It's not going to be pitch black out, right? But it's going to be weird. It's going to be worth witnessing. We can't change the date. People used to think the rays emitted were dangerous to people.
Aliens came from?
I haven't heard that, but yeah, I mean, again, back in the historical times, it's terrifying because you don't know why it was happening. So yeah, we talked about cloudy. You can get glasses almost anywhere. We sell them at the Science Center. We offer a bulk discount if you have a purchase of, is it 25? 50 or more, you get them for $1.50. We are in totality, but remember, it's qualified, right? It depends on where you are in that path. Getting closer to the center gives you a longer time period. We did not have a total, well, we did not have a total eclipse. We had a partial eclipse a few years ago. It was total further south of us. One of the great ones is, do I have to worry about my dog, cat, llama, goat, donkey looking up at the sun? Should they be wearing glasses? And I actually found a video that was going to use for something made by, I won't say who, but they actually showed like a horse with solar glasses on.
Like it's gonna
Like,
look at the sun normally.
Right. Those animals don't look at the sun normally. Your dogs or cats or hamsters are not going to look at the sun. So there's no reason to think they're going to do it during an eclipse. So, don't worry about that. I know you guys are interested about taking photographs, and one of the things I would suggest is you practice. I mean, there's a whole range of ways you can do this, right? You could just take this and put it right in front of your phone lens during the partial phase and take images. During totality, you're not going to need this, right? You're going to want to like just take a photo with your normal camera. If you're going to like go all out and use like a DSLR or a mirrorless thing or a telescope, again, remember you put that solar filter on the front, not the eyepiece. The exposure between the partial phase, even at 99% blockage, the sun is still 10,000 times brighter than a full moon. So the exposure between that phase and totality is dramatic. So you can go out any day at sunny and set up your camera and practice tracking the sun. The sun moves about its diameter every 2 minutes. So you're going to want to set up your tripod and your rotator or your tracker or whatever to be able to do that. And so you can practice taking photos of the partial phase at any time. The difficult thing, I think, is going from partial phase to now I need to take my solar filter off. I need to adjust my aperture and my shutter speed, and I still have to be tracking the sun, and I only have 2 minutes of time to do this. Two decisions you have to make. Am I going to try to expose for the corona, or am I going to try to expose for the bright ring around it? And those can vary by a factor of like an exposure of 1/8,000th to 1/8 of a second. I was talking with some photographers from the Blade a few weeks back, and we kind of went through all this sort of stuff. And so, the suggestion is, if you're going to attempt to do that, practice, practice, practice. You don't want to be exploring the menus on your camera during the eclipse. You should have muscle memory to know what to do. Boom, 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 take it off and put it back on and keep going. Most of the time when we talk to people about the eclipse, we say, don't attempt to take a photo of the eclipse. Why? Because you have at your disposal a $20 billion organization called NASA that's going to take way better photos than any of you ever will. And you paid for them already, right? It's tax dollars, right? You can use them. What would be more compelling is like that video we saw. Set up your cell phone on a tripod to capture you and your family and your reaction to what's happening. Because one, NASA can't do that. And 10 years from now, that's the thing you're going to want to share, is your reaction your grandkids' reactions, your kids' reactions to what is actually happening. We had one ambassador that was actually doing a, we call it family reunion. And we kind of talked with them, and they thought maybe we should do like an interview beforehand. And that video we showed you, we trimmed it down. NPR actually did that. They interviewed people ahead of time, said, so what do you think the solar eclipse is going to be like? And they're like, it's going to get dark. And afterwards, what did you think? And they're like, oh my God, I don't believe it. You know, they were like really emotionally changed from before and afterwards. And so, you know, if you're having a big gathering, interview people ahead of time and afterwards and kind of document their stories. It's kind of a cool thing to have. And you can get larger filters like this. We sell them in our gift shop. They're bigger, that, yeah, like that thing that you can sort of hold on the back of your phone. But again, practice, try it ahead of time to see what your image is going to look like, what your settings might need to be, and how you need to develop your muscle memory to do it. And if you want more details, I can talk to you afterwards about more specific stuff. Oh, and here are all the answers. Look at that. So yeah, I mean, we kind of talked about all that. So don't wear your glasses while you're driving. This website is amazing because it's not just for this eclipse. It's for like eclipses for the past 100 years and for eclipses coming up into the future. It's a Google Maps based thing. You can click on your location and it'll pull up when totality starts, how long it lasts, how fast the shadow is moving, all the different phases, that contact 1, contact 2, 3, and 4, and where you are in the path. It's really cool. And you just like zoom in anywhere and get all this information. And I know the next eclipse that's happening here in Toledo is in 2099, but there is actually one happening in 2044 in Montana, North and South Dakota, or in 2027, it passes through Egypt, right near the pyramids. So that could be and that one in Egypt, 6.5 minutes of totality. Which almost the theoretical limit is, I believe, 7.5 minutes. So, plus you got the pyramids, right? Pyramids, eclipse. The political situation is conducive to that. And so the other thing too, there are a ton of apps, this is just one of them, that you can get on your phone that you can use to pull up for your specific location where the sun will be in the sky on any given date. It's useful during an eclipse to see if your barn is in the way, if the neighbor's house, if the smokestack's in the way, or whatever. So that's one. This is what it looks like just outside the Science Center. We have the Prometica steam plant next to us. So at 3 o'clock, I didn't dial in the exact time, but at 3 o'clock, you can see the sun's going to be well up into the sky. The buildings around us won't be blocking us for our viewing party. So if you have the opportunity or the chance, if you want to come down, we'll be doing a big viewing party from 10 in the morning till 6 at night. We'll have food trucks, beer trucks, coffee, donuts, ice cream. We'll be building indirect viewers. We'll have some telescopes set up. And you get about 2 minutes of totality in downtown Toledo. So with that, well, thank you for having us.